Hey everybody, and welcome to day 2 of the Data Science Avocado. Yesterday we cut across the entire avocado, or the Data Science Avocado, and looked at how phrases like AI, ML, and deep learning kind of are related, and how does data science relate to those kind of concepts. Today, if we look at our agenda, we're actually going to start into the kind of core ingredients that we see as critical to successful data science deployments. And those roughly break down into the who, the how, and the what of data science. So if we jump out here and actually take a look at our vision, again, three main factors. I think it needs to remain pretty simple. Although the actual implementation of data science in practice can be difficult, and complex, we don't think that the practice itself or starting a practice should be. Again, we think it's just boils down to three main things: who, how, and what. So if we look at who should be doing data science? If you're starting from scratch, you really have two options. You can either develop your talent or you can go and acquire talent. And if you're developing talent, it probably makes sense to start in a place where, or start with a group of folks who are already doing something that lends itself, or that the day-to-day lends itself pretty well to what a data scientist is doing. I think actuarials probably have the biggest bone to pick with the phrase data scientist, because they've been doing data science in many ways for a very long time, or something similar to it. They've been doing a lot of statistical modeling. They've done a lot of forecasting. So those men and women have a lot of skills that can literally be one for one with data scientists. Others that can be really, really good and easy to train up are data analysts. So these are the men and women who are doing traditional business intelligence, right? So ad hoc reporting. Maybe they do a little bit of light statistical modeling, maybe have some good inferential statistics understanding, things like that. But they're not really doing hardcore data science. But maybe a lot of the skills that they're doing are foundational to true data science. And then there's finance. So I had a couple of finance buddies in college, and I was shocked to see how much time they were spending doing math. And actually in practice as well, a lot of them are doing pretty hardcore math as a part of their day-to-day functionality. So those folks can be really ripe to sort of transition over into data science roles. And the next question is kind of like, how do you do that? I have a whole set of opinions about how to do it. I'm a huge fan of Coursera, but I'm also a huge fan of going very, very deep in actual sort of traditional academic routes. But again, I have all sorts of opinions. If you have questions about that, please hit us up in the comments down here. The next idea is to kind of go and hire. So who should I be hiring? So we see a lot of requests for or job postings that are, I need 15 years of experience, and they need to know R, and they need to know Python, they need to be expert SQL developers. Oh, and they may need to be a full back-end developer. They need to be they need to be able to play the drums. They need to be able to paint and public speak, and they need to do all this stuff. And it's like, that just doesn't exist. Andy Likely here at Continuous calls those people purple squirrels. We got to stop looking for purple squirrels, because they don't exist. So what I like to really focus in on when I'm hiring true data scientists is I like to focus in on a little bit less less traditional disciplines. So the men and women who kind of grew up in the humanities. So this is like psychology, this is sociology, this is public health. A lot of those kind of humanities, those folks have pretty decent research skills. They understand hypothesis testing. They understand research methods. They understand experimental design. A lot of the things that are really fundamental to data science, these men and women have. And also, by the way, they have a truly broad spectrum of experiences, which is huge, because a lot of what data science is kind of being personable. It's being able to tell a story with data science. It's being able to kind of take something that is a little nebulous and show value in it. The next, for very similar reasons, is the hard sciences. So the physics, the biology, the neuroscience. I myself had a neuroscience background before I got into this. Engineering. So these guys and gals have all of those same kind of hardcore research skills, experimental design, all of that type of stuff. Added to that, they have hardcore math experience, and that can be very, very helpful. And then the last piece here is kind of a more umbrella term, which is just advanced degrees. So anyone with a research degree is going to come out of the program with really, really good research or really, really good experimental design. All the things that I said the other people would do, but they've also done a probably pretty good job or a fair amount, or had a fair amount of experience communicating the results of their work. That's huge. So their ability to kind of take this years sometimes of research and actually explain it in a 10-minute time period in front of a poster with their results is very similar in many ways to taking a huge data science project and pitching it to an executive at the end of the day. So these guys and gals have a lot of those skills, and those are kind of the folks that we ended up or that we end up focusing on when we're looking for new hires. All right, when you're hiring, start with a thoughtful plan. Don't just go willy-nilly hiring anyone who has, a set of skills that kind of meet your technical skills. I think it's really important to think about who you should be hiring first. And my recommendation is always to hire a player coach. And if you're not into sports analogies and you're more into IT, a working architect. So this person is pretty senior. They've probably had a little bit of maybe formal managerial or leadership experience. They're really heavy on data integration. And the reason that they're heavy on data integration is because, we see that as really foundational to any data scientist in general, right? So the ability to, go out, wrangle data, bring it together so that you can put it into a place that you can actually begin to build models or make inferences on is a huge skill set. And now we're not saying that this person has to make everything, all the data perfect and put it into a data warehouse. It's just sort of like their ability to go out and wrangle data to a place that they need it for their particular experiment or their particular model is very, very good. And the other piece that I talked about is that leadership skills or those leadership skills. This person should be or should want to kind of teach and coach and mentor younger developers, which takes me to my next point. So the next group that you should be hiring are junior to mid-level data scientists. So this is where you start to fill in that team. You don't have to go out and get another super senior data scientist and have 2 rock stars. Really what we think you should do, again, and this goes back to what the player coach is going to be good at, find people who want to grow, that are really, really passionate, that are going to work well with your player coach. So these people, 2-3 years of experience, they maybe have some pretty good background in data science. They've sat on a data science team, or these are folks that are coming from, some of those other existing job titles. They're actuarials, they're FAs, they're data analysts that want to make the leap because, hey, listen, I can't really get a data science job at my existing place, but I really want to learn. Here's what I've done. I've shown the ability to learn and understand advanced concepts. Can I work under this senior data scientist? That's who I would be focusing on next. All right, the last piece is kind of team structure. And I broke this down into 3 separate models. There's probably 1,000 different ways to kind of describe this. I kind of call it targeted, shared, and hybrid. So targeted is you basically have a data scientist for each of your individual lines of business that want them. And then you have a shared model where you have this center of excellence, and the data scientists are kind of shared by individual product, almost lent out to the individual business lines, most of the time in a project base. And then you have this hybrid where you have a center of excellence, but maybe you have a single data scientist on each one of the teams. I like one of these, and I don't like some of the others. I do not like a shared service. I think that it can be here's what I don't like about shared service. I think it gets to a place with prioritization that can very quickly be the legion of no, right? So, oh, no, we can't do that. Nope, we can't do that. Nope, we can't do that. Nope, we can't do that, because we've already picked these 2 projects. And I don't think that that does anybody any good, and it can be frustrating for the Center of Excellence, and it can be frustrating for the business line, because they're not getting anything done. You've kind of got that whole problem, traditional sort of like IT problem, where it's like, oh, well, I go to IT and IT says it's going to take 6 months to do this. I'm not going to wait for that. I like targeted a little bit more. I still don't like it very much, and here's why I don't like it. Or let's start with why I like it. I like it because the individual data scientists start to develop a level of expertise with their line of business that is kind of the secret sauce for, sorry, it's dinner time at my house, so we're trying to coordinate who's going to get tacos first. So give me another minute and a half and then we'll be done. So targeted, I like it because those data scientists become really, really focused in on a particular set of problems. They really start to talk the talk. They understand the business problems. They are dialed in to that individual business unit, which can be absolutely amazing for the business unit. And they serve their business lines very, very well. The problem that you run into is any sort of productionalization becomes very difficult at that point, because they may be running things on their desktop. One of the data scientists is writing in Python. The other one's in R. One of them likes to put things in Docker out on AWS. The other one doesn't automate anything. And the other one has things on Task Scheduler. So very, very quickly, you start to build silos, right? And so that becomes even more expensive and frustrating. So you guessed it, the thing that I really like is actually this kind of hybrid model where you have a core group of data scientists that are really responsible for setting standards, for automation, for a lot of the back-end functionality. Maybe this is where the leadership in data science sits. And then you have individual data scientists on the teams. And those data scientists get to share that, kind of focus on the individual business lines. But, they have a centralization kind of methodology. No, you can't just go and build this in whatever technology you want. No, you can't just do this. It allows a little bit of structure around this. And I don't mean to say that it's like this governing body that's like, no, don't do this, don't do this, don't do this. But at least makes it a little bit more thoughtful when you are making exceptions to the rule. Okay, yes, we can absolutely use that platform to do that because it's very well thought out versus, when you're a hammer, everything looks like a nail. All right, so that's who. That's kind of the talk for today. Thanks for joining. Look forward to tomorrow where I talk about, I think it's either either how or what you should be doing. I think it's how you should be doing data scientists or data science. So look forward to talking to you tomorrow. Thanks for joining today.